Hey guys, this is Miss Gill. We are doing lesson 2.4 today. This lesson is going to be done a little differently. You're not going to see me handwriting anything because I need to be able to show you some things on the screen. So I am doing things a little bit differently. All right, so let's just get started. This lesson is modeling with quadratic functions and guided notes. So you should be able to write quadratic equations to model data sets. We're going to use technology to find a quadratic model for a data set, and you can use quadratic models to solve real-life problems. So notice right here on your notes, there's a big section that says Notes for Desmos. I'm not going to put anything here personally. These are for you. So I'm going to go through Desmos, show you how to use Desmos to help you with this lesson. This is the technology piece. So anything you think you may need to help you remember what to do, where to go, that's where you're going to write it. Okay. So we're going to start off with example 1, writing a quadratic function. And we're going to do this using Desmos. So I'm going to show you how to do that now. All right, so before I do, I'm going to go ahead and read the problem. NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the heights h of t in feet of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers began to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. All right, so we're going to go to Desmos. It is desmos.com. You're going to hit Open Graphing Calculator. So when you open the graphing calculator, you are going to have a screen that looks like this. If you want to sign up and create an account, you can, but you don't have to. So first thing we're going to do is we're going to hit this plus symbol here, and we want a table. So in this table, we're going to take the data values from example 1. So we're going to take those data sets and we're going to type them in there. For example, we're going to do 0, well, if my 0, and then 21,000. So I'm going to come back when I have all of my data sets entered. Okay, so I have all of my data sets from example 1 from that table entered. So notice these numbers are in like large thousands. So we're going to need to zoom out quite a bit until we see those points. So they should create little points on your graph. So you can see right here, now we have some points. So I'm going to zoom in just a little bit, as much as I can there. All right, so notice we have those values. Okay, so what we're trying to do is we're trying to write an equation based on this information. And so we can get technology to help us with this, because remember, we have y equals ax squared plus bx plus c. All right, so we're looking to do an equation based on that. All right, so I added this what? Okay, lady, get with the program. This note, our equation is in standard form. So we're using this format to write our equation. All right, so in order to do that though, I have to type this in a little funny. So this may be one of those notes that you want to add to your Desmos. So we're going to do y, and then if you hit the shift button right above the escape, or tab under the escape button, there's that little mark. It's called a tilde. So that mark is important, so you may want to make a note of that. It's in between the escape and the tab button on your computer. So then we're going to type in our standard form equation. So ax squared plus bx plus c. All right. However, notice in our table, our values are x1 and y1. So we have to say that we want this equation to follow these values. So the way we do that is we go back and we got to put that subscript of that 1 just like it is in our table. So the way we do that is you would click on ABC. It gives you the subscript button right here. So we're going to click on that, and then we're going to do 1. And we have to do that for all our y and for all of our x values. I just find it easiest to go back at the end after you've typed it and put it in. Notice now something has popped up here, right? And I also have a graph here. I wish I could, I'm not sure. There is a way to zoom in just to the y and not the x, but anyways. So they've given us our answer, guys. So really, we don't really have to do anything. They're telling us, based on this data information, your A value should be -11, your B value should be 700, and your C value should be 21,000. Well, if we look, when X was 0, Y is 21,000. So that's definitely our C value because that's our Y-intercept. So now what we're going to do is we're going to write an equation in standard form, but now using these A, B, C values. So we're going to say -11 X, and we want that to be squared. Then we have positive 700 X, and then positive plus 21,000. So what this is verifying that this is the information to create a parabola that matches this. So if you take off the red line, so you can click right here to deselect the different graphs. Notice how my graph is changing from red to black. Notice that they are almost in the exact same spot, if not the same exact spot. So that tells us that these numbers definitely match this table that matches this equation. So this would be your answer. Yes, it's that simple. So now go to your paper. You may want to make some notes on your Desmos little area on things to do. Again, these are your notes, so whatever you think you may need. And then I'm going to go on my paper and I'm going to type in the answer here. All right, so the function that we found, since our word problem tells us h of t for height, I am going by those and using those values h of t for our equation. So now it does say after about 20.8 seconds, passengers began to experience a weightless environment. So we're supposed to evaluate a function, or this function, to approximate the height at which this occurs. So this means we're looking for when h of 20.8. So by now you guys should know that yes, we could plug in 20.8 here. So go ahead and you could do that now. So you can plug in your 20.8, go through here and solve to see what you get. So you should have gotten that this equals approximately 30,800, I thought I was typing, 800.96. So what does this mean? This means that the passengers began to experience a weightless environment at about 30,800 feet. So there's our answer in words. So I want to show you another neat trick, since we have technology and we're using it today, on how we could do this without doing all this work. Okay, so I'm going to go back to Desmos. I'm going to change this to be f of x. All right, so the reason I'm going to do that, and hopefully this works because it's been a while, is I'm going to type in 20.8. And notice all I did was I typed in, now you do have to have this function here. So again, if you want to add that note to your paper, and then you put in the number and voila, it does all the math for you. So sometimes technology is great. All right, but just know that, what does this mean? This means on the graph where your x value is 20.8, your y value is 30,800.96. Okay, so that is our first problem. All right, so that's our first example. We found all the answers there. Now we're going to do example 2. So in this one, this one's not going to give us nice round whole numbers. So the last question in the past, I showed a very extremely lengthy way on how to get that answer without using technology, and Ms. Gill learned that once you learn how to use the technology, it's so much easier and helpful, so why not just go that route from the beginning? So we're going to go to Desmos, and we're going to plug this into our thing. So I'm going to go delete all the stuff that we had, and I'm going to put in this table instead.